So ER diagram. ER diagram. What is ER diagram? As its a name, it is a diagram. Diagram means what? To represent the ER model with graphically. So ER diagram can express the overall logical structure of a database graphically. For which purpose ER diagram is used? We know this is ER model. In ER model, these are the entity set, these are the relationship set between that entities. For these entities, these are the attributes. But how to represent it? So to represent it graphically, a logical structure is used that is known as ER diagram. So an ER diagram can be expressed the overall logical structure of a database graphically. Now the ER diagram, it is drawn with the components. That components now we are going to learn here. So what are the components when we draw ER diagram? First component of ER diagram is rectangular, which is divided into two parts for represent the entity set. So how we represent the entity set in ER diagram? I am going to draw here. It is a rectangle divided into two parts. So what is the first part? The first part is the name of that entity set, and the remaining second part, it is the name of all attributes of the entity set. So here instructor is an entity set. This is one rectangle which divided into two parts. So instructor is an entity set, and what are the attributes of this entity set? The attributes of this entity set are instructor ID, name of the instructor, department name of the instructor, and salary of that instructor. Okay. So in this way, a rectangle is used which is divided into two parts to represent an entity set in ER diagram. So I similarly draw here student with SID, name, department name, and credits earned by that particular student. Now the next one. So diamonds. Diamonds represent the relation between these entity sets. So I draw here diamond as a relation between these two entity sets. So what is the relationship set between the instructor and the student? Advisor is the relationship between the instructor and the student. Advisor is the relationship set between the instructor and the student. So here the diamond is used to represent the relationship set. Next, undivided rectangle represent attributes of that relationship set. Undivided rectangle, you represent the attributes of the relationship set. What we call that attributes? We call it as a descriptive attributes of that relation. So undivided rectangle means single rectangle, not divided into parts. For example, for advisor, suppose date is a descriptive attribute of that relationship set, then we represent it as a undivided rectangle. Now the next one, attributes that are part of primary key are underlined. The attributes which is part of primary key are underlined. So in the instructor, what is the primary key? ID is the primary key, so it is underlined. In student, SID is the primary key, so it is underlined. So the attributes that are primary key are underlined. Next, lines. Link the entity set to the relationship set. The lines, solid lines. Okay, solid lines are used to link the entity set with the relationship set. So this line and this line. What it link? It link this entity set with the relationship set advisor. It link this student entity set with the relationship set advisor. Along with the solid line, dotted lines are also used. So dotted or dashed lines link the attributes of a relationship set to the relation. Means if the relation has its own descriptive attributes, that attributes are linked with the dashed lines. Means that is the descriptive attribute. So it is linked with this advisor as a dashed lines. It is linked with the advisor as a dashed lines. So these are some simple or major components of ER diagram. The first one is the rectangle divide into two parts. So instructor which represent the entity and the attributes of that entity. Then diamond represent the relationship set between the entity set. 2, 3 binary. If it is a binary relationship set, it is between the two entity set. If it is a ternary, 3 and depending upon the degree of the relationship set. Undivided rectangle represent the descriptive attribute of a relationship set. Attributes that are part of the primary key are underlined. So IID and SID underlined here. Lines, solid lines, these are links between the entity set and the relationship set, and dash lines, these are the link between the descriptive attribute and the relationship set. Along with that, the double lines that we will see afterwards, double lines that represent the total participation. Sorry, double lines that represent total participation. Means in the advisor relation, the student is totally participated. So here we use double lines. What it indicates that the student entity set totally participate in the advisor. While single line indicates partial or total, not necessary, but if it is total participation, then double line, solid lines are used, indicating that that entity set participate in that relationship set is a total participation. And double diamonds represent the identifying relationship set linked to the weak entity set. And what is that weak entity set and all these things we will see afterwards. So double diamond, only remember that the double diamond in this way, this double diamond, it represents the identifying relationship set which link the weak entity set to the strong entity set. And what is the weak, what is the strong entity set, all this part we will see. That is about the simple components of ER diagram. Now, the next in detail we are going to see the ER diagram. Small concepts of ER diagram now we are going to see here. The first thing is that how to represent the mapping cardinality. Here we have seen that there is a diamond in between two entity sets. This is the first entity and this is the second entity. Entity E1, entity E2, and this is the relation R. So diamond is used to represent the relationship set between the two entities E1 and E2. And now see here, this relation is depend upon the mapping cardinality. Either it is 1 to 1, either it is 1 to many, many to 1, or many to many. Now how to represent this mapping cardinality with the help of this diagram, or in the diagram how we can represent the mapping cardinality, that part now we are going to see with example. So first, this example already we have seen. The relationship set advisor between the instructor and student entity may be 1 to 1, 1 to many, many to 1, or many to many. So we express the cardinality constraint by drawing either a directed line, which indicate 1, which indicate 1 means 1 to many. In that 1 represent with directed line and undirected line which represent many. Directed line which represent 1 and undirected line which represent many. That in that way we represent the cardinality constraint in the ER diagram. Now see it with example. The first one, one-to-one relation. So if there is a one-to-one relationship between the instructor and the student, means what? One instructor associated with at most one student. Okay, one instructor associated with at most one student and one student associated with at most one instructor. So that is one-to-one relationship set, advisor between the instructor and student. So one, how we represent? We represent it with the arrow. One, how we represent it with the arrow or directed line. See, the arrow in this direction is not allowed. I will draw it here. If it is a one-to-one in this way, sometimes student do in this way. It is not allowed. Remember that. It is not allowed. The direction is always from relationship set to the entity set. The direction is always from relationship set to the entity set. So, here one-to-one is represented with the directed line. This one direction is not allowed. Means never make an arrow towards the relationship set. It is an arrow directed line towards only the entity set. So in this way one-to-one is represented. Next, one-to-many. So one-to-many relationship set between the instructor and the student. From instructor to student, it is one-to-many. See, from and to, this word is also important. One-to-many, from instructor to student. So from instructor to student means one instructor, many student, and one student associated with at most one instructor. One instructor associated with many number of students, one student associated with at most one instructor. So how to represent? It is one to many, means one at the side of instructor. So arrow and the directed line is towards the instructor and undirected line is towards the student, indicating that one to many. One student, many, one instructor, many student. In the same way, when it is many to one, opposite. If it is a many to one from instructor to student, if it is many to one from instructor to student. So, one instructor associated with one student only. One instructor associated with one student only, but one student associated with any number of instructor. One student associated with any number of instructor means it is many to one from the student instructor to the student. So, at in student side it is one, directed line is towards the student side, and the instructor side it is undirected line indicating many. That is simple many to one representation in the ER diagram. Next, many to many, again the simple undirected line towards both the sides. Undirected line towards both the sides. It is a many to many from instructor to student. That's why undirected lines. That is about the one-to-one, one-to-many, many-to-one means how to show the mapping cardinality with the help of ER diagram. We move to the next. So, alternative notation for cardinality ratio. So this is normally not used. The lines under directed and undirected line, it is a simple way to represent the cardinality. But there is the alternative notation is also available. So what is this alternative notation we are going to see? So cardinality limits can also be expressed with the participation constraint. A line may have an associate minimum and maximum cardinality. Means the value is given there. Minimum and maximum cardinality. The values are given there in the way of L and H. L indicates minimum and H indicates maximum cardinality. L indicates minimum cardinality and H indicates maximum cardinality. So a minimum value 1. A minimum. So in this case, this is minimum cardinality and this is maximum cardinality. Okay. This is minimum cardinality and this is maximum cardinality. So a minimum value 1 indicates here the minimum value 1 means it's a total participation. At least one entity in the entity set participate in that relationship set. Minimum value 1 indicates it is a total participation. Means at least one entity in the entity set participate in that relationship set. Means here in this case the minimum value 1 indicates the student entity set participate in at least one relationship set or participate in that relationship set or associated with the instructor through that relationship set advisor. At least one means total participation. So a maximum value 1 in this example, maximum value 1 indicates the entity participate at most one relation. Means one student associated with at most one instructor. So that is the maximum value 1 indicate. What it indicates? That entity set participate in at most one relationship set. Minimum 1, maximum 1. So it is 1 to here one student associated with only one instructor. And star indicates many, no limit. So 0 to star means any number. 0 to star means any number. Means this one simply like this. One instructor associated with any number of students, but one student associated with at most one instructor. So in this way the cardinality we can represent with L and H value. L indicates minimum, H indicates maximum, but representing with a directed and undirected line is very simple than representing it with L and H value. But this is an alternative notation that you people also know about it. Now the next one, how to represent the composite attribute and its components, derived attribute and multivalued attribute in the ER diagram. So here the instructor entity set is given here with multiple multiple attributes. Normally we have seen ID, name, department name and salary, but here for example the instructor entity set, it is an entity set instructor which is represented as a divided rectangle, two parts. First part as the name of the entity set and second part is all the attributes of that entity set. So what are the attributes of this entity set? First one is the ID, which is the primary key and that's why it is underlined. All types of attributes are shown here as an example. First one attribute is the ID, which is underlined, means it is a primary key. Then second attribute name, it is a composite attribute. It is a composite attribute. These are three components of this composite attribute. So you can see it is shown with the intent, means this one, and then after paragraph or tab we can say intent. We use in Python in this way. Intent is used here to indicate that these are the three components of this composite attribute. Similarly, address is a composite attribute again, whose component attributes are street, city, state and zip. Street is again composite attribute, which again three components: street number, street name and apartment number. Street number, street name and apartment number. So in this way, composite attribute is shown with the help of intent. Then phone number. Phone number is a multi-valued attribute. How it is represent? It is represent in the curly bracket, indicating that it is a multi-valued attribute. So when you draw the ER diagram, you need to remember these simple notations also. Date of birth, it is a simple attribute. Okay, it is written as it is. Then age. Age is a derived attribute. After that, empty bracket or is used. Empty bracket is used to indicate that it is a derived attribute. So remember that when we draw ER diagram and entity set, it is draw with the help of divided rectangle. First part one is the entity, name of the entity, and the second part include all the attributes. So here ID, it is underlined indicating it is a primary key. Then name and address, these are composite attributes. Phone number is a multi-valued attribute. It is in curly bracket. Date of birth, simple attribute. Age is a derived attribute. So empty bracket is used after it. That is about the representation of different types of attributes in the particular entity set. Now the next one, ternary relationship set. How we represent a ternary relationship set? So the three entity sets are there. Participant, one is the instructor entity set, second one is the student entity set, and third one is the project entity set. These three entity set participate in the relationship set project guide. So student, project guide, you can write here project ID or group number, you can say, and project title, then leader of the project, project leader. In this way, the attributes may be there for the project. And project guide is a ternary relation between these three entity set, and this is represent in this way. The link is between the entity and in this way. Entity sets and relationship set. So in this way, we represent ternary relationship set in the ER diagram. Now tell me, or what are the attributes of this relation? So the attribute of this relationship set project guide are the primary key of instructor. I write here IID so that it is easy to understand. SID is the primary key of student, and the primary key of project, that is project ID. So these are the attributes of this relationship set. Now what is the primary key? What is the primary key? It, as all these are many to many. So the union of all these is the primary key of project guide. So the primary key in this case, primary key of project guide relationship set is IID, SID and project ID. The union of all these. Why? Because all are many to many. And that's why the union of all these together becomes the primary key of this project guide relation. So in this way, ternary relation we can represent. Now the next part, that is again which is very important in the case of ER model or ER diagram, and we need to understand this part also, that is weak entity set. What is mean by weak entity set? So as per the definition, an entity set that does not have a primary key is referred to as a weak entity set. An entity set that does not have a primary key is referred as a weak entity set. Then strong entity set, opposite definition, an entity set that has its own primary key is known as strong entity set. So up to this, whatever the entity set we have seen, all are strong. Instructor has instructor ID as a primary key, student ID, then course ID, then department name. So these are the entity set which has their own primary key, and that's why these are strong entity sets. But an entity set that does not have a primary key is referred to as a weak entity set. Now we are going to try to learn it with the help of example. So for a weak entity set to be meaningful, it must be associated with another entity set called the identifying or owner entity set. For a weak entity set to be meaningful, it must be associated with another strong entity set called identifying or owner entity set. So every entity set, weak entity set, must be associated with an identifying entity set. That is, weak entity set is existent dependence. Okay. Now see with example. A weak course relation, course entity set is there. Okay. With course entity set with course ID. Then in the course title is there and credits of that course. Okay, try to understand these concepts. Weak entity set. So course entity set is there with course ID, title and credits. Among that, the course ID is the primary key. So we call it as a strong entity. Why? Because it has a primary key. For example, when we represent course in the table form, how we represent it? 1 minute. I draw here. Course ID, then title and credits. So in our case, UCSC 501, I think title of the course is, I write here, computer algorithm. UCSC 502, suppose OS. UCSC 503 DBE. UCSC 531 as DBE lab. Okay, credits 3, 3, 3, 1 in this way. So every course has its ID, correct? And that's why it is a strong entity set. Primary key is there, so why it is a strong entity set. But there is another entity set section which is with, I will draw here section. With attributes section ID, then semester and year. Okay. Now, these are the sections which come under this course. Okay. These are the sections which are comes under this course. So, the relation between this section course. Okay. Now, I draw here in the same way the table for the section. For example, under UCSC 503 database engineering, there are 6 sections: unit 1, unit 2, unit 3, unit 4 and unit 5. So I write here section. This is example semester and year. So unit 1, unit 2, in this way up to unit 6. Now what happens? I go for another course UCSC 501 as a computer algorithm. This course also has its own section: unit 1, unit 2, unit 3, unit 4, unit 5, unit 6. So this unit 1, unit 2, unit 3, whatever the section ID, is it sufficient to identify every entity in the section when we write all the section together? So in this unit 1 of CA is also there with the semester, fifth semester, okay, fifth with year 2021. So here unit 1 is also there for semester 5 year 2021. So how I recognize this unit 1 and this unit 1? This unit is under UCSC 503 and this unit is under UCSC 501. Means this section entity set, it depends upon the course entity set for its existence. It depends upon the course entity set for its existence. It does not have its own primary key. We cannot say that section ID, semester and year, anyone is the primary key. Okay. So the section is depends upon the course. This section entity set is depends upon the course for its existence. That's why it is known as owner entity set, or we call it as an identifying entity set, and this section is a weak entity set. Why? Because it does not have its own primary key. This section among itself need to be identify the entity. So these three becomes the what we call it as the attributes which are used to identify every entity in that entity set. We call it as a discriminator. What we call it as a? We call it as a discriminator. Instead of primary key, it is known as discriminator. So in this section, all these three attributes together form the discriminator, and discriminator is shown as a dashed underline. Instead of here solid underline is used, solid line is used, here dashed line is used, indicating discriminator of that weak entity set. Discriminator of that weak entity set. And the relation between these two, it is known as identifying relationship set. It is known as identifying relationship set. The relationship between a strong entity set and the weak entity set, it is known as identifying entity or identifying relationship set, and it represent in ER diagram with double diamond. It represent in ER diagram with double diamond. That is the last component of ER diagram, that is double diamond, to represent the identifying entity set. So the relationship, again I am repeating, the relationship set associating the weak entity set with the identifying entity set is called identifying relationship set, and it must carry three properties. See, it is always there with the identifying relation that every identifying relation follow these three properties. Which are these? The identifying relationship set is always many to one from weak entity set to the strong entity set. So again I draw in short here section and course. And in between the identifying relationship set, that is section course. It is always many to one from weak entity set to the strong entity set. So how we represent it? Many to one. One is towards the strong. That's why it is many. One course, multiple sections are there. So it is always many to one from weak entity set to the strong entity set. The participation of weak entity set is always total. So how we represent it? With double line. The participation of the weak entity set is always total. So we represent it as a, means every section entity is participate in the section course relationship set. That is total. And the identifying relationship set should not have their descriptive attribute. Means for this, no descriptive attribute is there. Should not have their own descriptive attributes. Why? Because it is a relationship set between a strong and weak entity set. That's why it should not have its own descriptive attributes. So that is here shown with this diagram. Whatever I have drawn previously, it is there. So section discriminator as dashed underline, then primary key of this section course, etc. Now see how we represent the section course here. It is a relationship set between the two entity set. So what is the primary key of this relationship set, or what is the primary key of section? Sorry, it has no primary key, its own primary key. So what is the primary key of a weak entity set? How to find out? For that, we need to add the primary key of course in the discriminator of the weak entity set to form the primary key of weak entity set. So again I am repeating the how to identify the primary key of weak entity set. It is formed by, or it is a union of primary key of strong entity set on which the weak entity set depends, and the discriminators of that weak entity set. So what is the primary key of section course? This section, primary key of section, it is the combination or union of primary key of strong entity set on which it depends. So it is course ID and the discriminators of weak entity. What are the discriminators of weak entity? Section ID, semester and year. So all these together 4 becomes the primary key of section. What is the primary key of section? Primary key of strong entity set on which it depends and its own discriminators. So all these together becomes the primary key of section entity set. So that is given here, primary key of section. Now this is the ER diagram of our university database that we will discuss now. So when we consider all these things together, the different entity sets, major entity sets of university database are, first we start with department name, building budget. Among that department name is the primary key, so it is underlined. Then student and instructor, next entity set which is very important, department, instructor, student. Similarly, course is another entity set with course ID, title, credits. Section is a weak entity set which depends upon the course. Then time slot, classroom, these are another entity sets. So these are the major entity sets along with their attributes. Not all attributes are considered here. For sake of simplicity, some attributes we considered here. Now the relationship set you can observe here. Between the course and the department, the relation is course department, which is many to one. Which is many to one. You can observe here, many to one. And the participation of course is total. Why? Every course participated at least one department. UCSC 503, UCSC 501. These are the courses which are for the department computer science. So every course, if it is exit, it is associated with at least one department. And that's why this participation is total and it is represented with double line. Similarly, instructor department, if there is an instructor myself, as an instructor, I am associated with one department, that is computer science. So it is many to one from instructor to the department. Instructor to the department. One department, multiple instructor. One instructor associated with at most one department, and the participation is total. Why? Because every instructor there, if there is an instructor in the institute, it is always associated with at most at one department. So it is total participation and always many to one. Similarly, in the case of student, it is again many to one from student to department, or you call it is an opposite way. It is one to many from department to student. In this way also I can say. See, these two statements carry the same meaning. I say it is the student department. It is many to one from student to department. Okay? Or I can say it is one to many from department to student. Both carry same meaning. It is one to many from department to student means one department, many students are there. So one department, many students, many to one or one to many you can call. Its participant is total, because if there is a student enrolled in the university, it must be associated with at least one department. And that's why it is many to one and total participation. Now, instructor and section, you can observe here it is many to many. One instructor may have multiple section. I am teaching you. I will teach. I am also teaching MTech subject. I am also project guide for final year students. So one instructor many section can conduct or teaches, and one section can be taught by multiple teachers. It is possible. So here teaches, it is many to many. Takes is also many to many. Student, one student, multiple section enrolled. One section, multiple students are there. Text has its own descriptive attribute, that is grade. You can observe here. Then this course section already I have taught you as a weak entity set. Similarly, section in this way, these are there. So it is a single relation, relation among itself. So prerequisite, as I told that UCSE 503. What is the prerequisite for that? UCSE 302 data structure. Means that course is prerequisite for another course. So that is shown with this single relation. Relation for that particular entity set within. So in this way, university scheme ER diagram, I represent it here.